the dark areas. These are the stripes we can see on the screen. Sweet. Let's get stuck into parallel and series circuits. Irresistible. First, you need to know these 12 circuit symbols. You've got 5 seconds. But you do them anyway, right? Right. Circuits come in 2 variations, series and parallel. But what's the difference? In a series circuit, there is only one possible route for current to get from one side of the cell to another. In a parallel circuit, it can take more than one route. It can go through this bulb or through this one. What the heck? Why not do both? Current is flow of moving charge. The more charge flows, the higher the current. In a series circuit, the current flows through each component in turn, and there are no alternative routes. Each part of the series circuit has the same current, measured in amps. Nice moped! In a parallel circuit, the current has to divide itself between the different paths. These 2 bulbs are identical. So in the parallel part of this circuit, the current is split in half, and each bulb gets just 0.1 amps. Okay, but why does current flow? Why bother setting out from that cosy little cell in the first place? The electric charge wants to get from one end of the cell to the other. For electrons, this is like going downhill. They love it. But they can't go through the cell, not allowed. So they have to go round the circuit. The difference between the ends of the cell is called the potential difference, and it's measured in volts. For the standard cell, this is 1.5 volts. In a series circuit, the potential difference is shared. So these 2 identical lamps share the 1.5 volts from the cell, half each. But in this parallel circuit, both bulbs have the full potential difference across them. So opposite things happen in series and parallel circuits. This being science, we'll measure stuff, namely the current using an ammeter and the potential difference using a voltmeter. First, current. How do we measure the current flowing through this bulb? The ammeter will tell us the size of the current measured in amps. It needs to go into the circuit in series to measure the full current. Yep, round about there. And to measure the potential difference across the bulb, the voltmeter has to be connected in parallel. That way, we measure the same potential difference as is across the bulb. Positioning is everything. The usual type of cell supplies 1.5 volts. If we put 2 together in series, then the potential difference is doubled to 3 volts. That's enough to power some pretty cool stuff. If we join them the wrong way, it's not going to work. The potential difference of one cell is cancelled out by the other. No current flows. If we add more batteries, we increase the potential difference across a component. We're also increasing the current. Eventually, the component will break. Shame.